Welcome students to this class of mathematics. So in yesterday's class we discussed about the basic definition of a matrix, its order, rows, columns, general representation of a matrix and all such basic things about a matrix. So now we proceed further. So today I am discussing in this class chapter 3 matrices of class 12th, and we start from types of matrices. First type of matrix that we are going to discuss about is a column matrix. What is a column matrix? It is a matrix which has got only one column. Now this I have discussed in my previous class that all the horizontal lines are called rows and all the vertical lines are called columns in a matrix. So this is a matrix which is containing only one column and it can have any number of rows. As you can see that it has one column but it has got 1, 2, 3, 4 elements in this first column. So let us count the number of rows. First row, second row, third row, fourth row. So it has one column and 4 rows because horizontal lines are containing only one element. So such is the matrix, such type of matrix is called a column matrix. Now we come to the second type of matrix, which is a row matrix. So what do we mean by a row matrix? Any such matrix which has got only one row. Now since this is the horizontal line and you can see it is enclosed by this square bracket and it is denoted by a capital letter B. So it's a matrix but it has got only one row. Let us count the number of columns. As we know that vertical lines are called columns. So let us count the vertical lines. 1, 2, 3, 4, 5. It can have more columns, it can have less columns. But the number of rows, it will have only one row. This is the definition of a row matrix. Next is a square matrix. So what do we mean by a square matrix? As you can see, the word suggests that this matrix has got a square shape. And when will it take a square shape? When you can see that the number of horizontal lines and the number of vertical lines are same. That means as many rows, as many columns. As you can see in this matrix, number of rows are 2 and number of columns are also 2. So what is the order of this matrix? 2 by 2. I have explained it in my previous video that order of a matrix is denoted by first writing the number of rows and then the number of columns. So this is the number of row and this is the number of columns. So this is a 2 by 2 square matrix. Now we can have a 3 by 3 square matrix also, as you can see here. You can see that this is matrix B, in which the number of rows are 1, 2, 3 and number of columns are also 1, 2, 3. So such type of matrices are called square matrices. In general, A, Aij, M cross M. So you can pay attention that I have written M cross M. That means rows, number of rows and number of columns are same. So in general, we represent any square matrix in this manner. Let us understand the meaning of a diagonal. So if this is a square matrix, what do we mean by the diagonal of this square matrix? For that, we consider this matrix A. As you can see, matrix A is a square matrix. Why it is a square matrix? You can see, you can count the number of rows 1, 2, 3. You can count the number of columns 1, 2, 3. So it is a 3 by 3 square matrix. Now before proceeding forwards, I can tell you that the square matrix can be of any order. 2, that means 2 rows and 2 columns. 3, that means 3 rows and 3 columns. 4 and so on. So here in this course of class 12 mathematics, we are going to stick till the square matrices of order 3. So if this is a square matrix of order 3, so can you see these elements? What is the speciality of these elements? A11, first row, first column, A22, second row, second column, and A33, third row, third column. These elements are called diagonal elements. This line is called the diagonal. These 3 elements constitute the diagonal of this square matrix. So what are the diagonal elements? So in general we can say all such elements whose both indices are same, 1 1, 2 2, 3 3. All such elements of a matrix whose indices are same, they are called diagonal elements. Pictorially you can see that this diagonal, this left to right, we are considering only one diagonal. Now there is some confusion to some students. They ask me sometimes, ma'am, is this also a diagonal? No, this is not considered as a diagonal of a matrix. Diagonal of a matrix is only this line. Only these three elements are constituting the diagonal. These three elements are not constituting the diagonal. So we are not going to consider these elements anywhere for diagonal. So I think it is very clear to you students that what are the diagonal elements. Now let us come to this matrix, matrix A. Now we can see that matrix A, it is also a square matrix. So can you tell me which elements are diagonal elements? 1, 4, 6. So we can even join them. No, there is no need to join them while you are doing the calculations or routine questions. It is just to explain you that I have joined them and made a diagonal. So the diagonal of matrix A, of a square matrix A, which is a matrix of order 3 cross 3, is constituted by the elements 1, 4 and 6. Now next thing I want to make clear is that we consider the diagonal only in a square matrix. If the matrix is not square, we are not going to talk about the diagonal of that matrix. So I hope students I have made myself clear. Next type of matrix is a diagonal matrix. Previously I explained you only the diagonal of a square matrix. Now I am talking about a different thing. Now I am talking about a diagonal matrix. So what is a diagonal matrix? The first condition for a matrix to be a diagonal matrix is that it has to be a square matrix. Only square matrices can form a diagonal matrix. As you can see in these examples I have taken a matrix B. And why I am calling it a diagonal matrix? Because only the diagonal elements are non-zero and the rest elements are 0. You can see matrix C, it is a 3 by 3 square matrix. You can see its diagonal elements are non-zero and it's all non-diagonal elements, means all those elements which are not lying on this diagonal, they are all 0. So what is a diagonal matrix? Any square matrix is called a diagonal matrix if all its non-diagonal elements are 0. I think it is very clear to you students that its all non-diagonal elements are 0. Now we consider a scalar matrix. So what is a scalar matrix? I have right now explained to you a diagonal matrix. So what was a diagonal matrix? It was, why I am explaining again the diagonal matrix? Because both of them are related to each other. In diagonal matrix, first of all the matrix has to be square, then its diagonal elements have to be non-zero and all non-diagonal elements are 0. But in scalar matrix there is one more added property. What is that? You can see in these examples that diagonal elements are non-zero but they are equal also. So any diagonal matrix whose elements are equal is called a scalar matrix. Means the matrix has to be a diagonal matrix. So how many properties it has to satisfy to become a scalar matrix? Number 1, it has to be a square matrix. So you can see B and C, they are both square matrices. Number 2, their non-diagonal elements are 0. And number 3, their diagonal elements which are non-zero have to be equal. Let us compare this scalar matrix with diagonal matrix. In diagonal matrix you could see that non-diagonal elements are 0 but diagonal elements are, they may be unequal. Diagonal elements are non-zero but they may be unequal. But in scalar matrix these diagonal elements are to be non-zero and they are to be equal also. Next matrix that we are going to discuss is identity matrix. So what is an identity matrix? The first condition for a matrix to be an identity matrix is that it has to be a square matrix. Now students, you can see these examples. This matrix is a square matrix. Its non-diagonal elements are 0. Diagonal elements are non-zero, but they are only 1. Similarly, you can see this matrix. It is a square matrix. All its non-diagonal elements means those elements which are not lying on this diagonal, they are called non-diagonal elements. So they should be all 0. So what is an identity matrix? Whose non-diagonal elements have to be 0 and diagonal elements are all 1, no other number other than 1. So I1, we denote any identity matrix by writing its order here. I1 means identity matrix of order 1. This is a matrix of order 1, 1 by 1, 1 row, 1 column. Since this is the diagonal element, single diagonal element, so this is 1 and there is no non-diagonal element. Identity matrix of order 2, so order 2 by 2, that is why we have called it I2. So diagonal elements 1, non-diagonal elements 0. Identity matrix of order 3, diagonal elements 1, non-diagonal elements 0. So what do we mean by an identity matrix? A square matrix in which all diagonal elements are 1 and rest all the elements are 0 is called an identity matrix. In general, I can write if A is equal to Aij n cross n. Students, you must be knowing that this is the notation for writing a square matrix. If it is a non-square matrix, I would have written m cross n, but since it is a square matrix, I have written the order n cross n. Aij, what is Aij? Aij is the general element, any general element of this matrix. So this general element is 1 if I is equal to j. I is equal to j. Where I is equal to j? I is equal to j only for diagonal elements, and Aij is 0. Where Aij is 0? It is 0. It is 0 when I is not equal to j. That means for rest of the elements. So whatever I have explained you here, this is another way of writing that. So you must have been clear by this identity matrix, and identity matrix satisfies all properties of becoming a diagonal matrix also, and all properties of a scalar matrix also. So every diagonal matrix is a scalar matrix also, and it is a diagonal matrix also. Converse may not be true. Now let us come to the another type of matrix, which is the zero matrix. So what do we mean by a zero matrix? A matrix is called a zero matrix. It is clear from the name, whose all elements are 0. So this is the zero matrix of order 1 by 1. This is the zero matrix of order 2 by 2. Generally, this zero matrix is denoted by the capital letter O. So we can write that this matrix is equal to capital letter O. So zero matrix is denoted by capital letter O. Now students, there is one confusion. Sometimes there is a confusion to the students. They consider that is zero matrix necessarily going to be a square matrix? No. It may be a square matrix, it may not be a square matrix. 0 means that all its elements are 0, whatever its order may be. You may be confused since I have taken both the square matrices. So I can take this one as non-square also. So I can let me make its order 2 by 3. So it is also a zero matrix now. Now let us consider the equality of two matrices. When do we call two matrices to be equal? So there are two conditions, students, for two matrices to be equal. Consider two matrices A equal to Aij, B equal to Bij. Then these two matrices are said to be equal if, number 1, they have to satisfy two conditions. First, they are of same order. A and B will be equal if, number 1, they are of same order, and number 2, each element of A is equal to the corresponding element of B. For example, I think it is easier for us to understand anything with the help of examples. You can see these two matrices. First thing, they are satisfying their condition of orders. The first matrix is also of order 2 by 2 and the second matrix is also of order 2 by 2. It is very clear to you, students. Now you can see that each element is equal to its corresponding element. So what do you mean by corresponding element? 2 is the element of the place A11. It is equal to the A11 element of other matrix. This element which is at the place A12, it is equal to its corresponding element. This is equal to its corresponding element. This is equal to its corresponding element. So these two matrices were equal because they had same structure and every element was equal to the element of the other matrix which was at the same place. 2 is at the place A11. This also at place A11. So I hope you must have understood the equality of two matrices. Now consider this example. In this example, they have given you, this is a question, they have given you that the two matrices are equal. It is given to you in this question that the two matrices X, Y, Z, A, C, D and this, they are equal. So you can see that their structures are same. What do you mean by structures? You can see the order of first matrix. Now let us recall how do we write the order. We count the number of rows 1, 2, 3. So rows are 3 and how many columns? 1, 2, 2. So its order is 3 by 2 and we see that the order of this matrix is also 3 by 2. So these two matrices, we can see they have got the same order and it is given to us. I am not saying that they are equal, it is given to you in the question that they are equal. Keeping this thing in mind, you have to find the values of X, Y, Z, A, C and D. So you can see that if these two matrices are equal, that means their corresponding elements are equal. What does it gives you? It gives you X should be equal to 1.7 and what is the corresponding element of Y? It is 0. So X is 1.7, Y is 0, Z should be equal to 3, A should be equal to 4, C should be equal to 1 and D should be equal to 2. So I hope the equality of two matrices is also clear to you. Now students, I end today's class here and in my next video I am going to discuss operations on matrices.